So for our notes for today, we are dealing with residuals, which residuals is kind of a difficult concept for some people to understand. A residual basically is what's left. So like for example, the most common residual that you are going to ever deal with is if you're leasing a car. You lease the car for, a few years, and then at the end of the few years, they'll tell you you can either bring the car back in and you can lease a new car, or you can buy this car for what they refer to as the residual value. So for those few years when you've been leasing the car, you've paid so much of the cost of it. Let's say it's like a $20,000 car. You leased it for 3 years, so you paid like $12,000 of it. So they say the residual value is another $8,000. So you can buy it for that rest of the $8,000 to pay off the total price of it, or you can get a new one. So your residual is your what's left, is basically what that stands for. So when we're dealing with residuals as far as data goes, you need to figure out how far above or below your point is from the line of. So we did our line of best fit last class. We took our scatter plot, calculated our line of best fit. So now we need to figure out how far above or below that line of best fit our points actually are. That is our residual. So right here is how we calculate it. Your residual value is the actual value minus the predicted value. So that line of best fit, that is our prediction of where the data should end up falling. So over here I have for you, to remind you, actual value, that is your table that you're given. That point is your actual value. Predicted, you plug into the equation, meaning your line of best fit. That gives you your prediction of where you should be based on the trend of your data. Positive residuals are above your line of best fit, and negative residuals are below the line of best fit. So here, So here we have the problem we were dealing with last class, where we had our study hours and our region score. We figured out that that was our line of best fit. So over here is a picture of our scatter plot. Here's our line of best fit, going right through the middle of the data. So these points up here are all positive residuals because they are above your line of best fit. So then these points down here would be what? Negative residuals, because those are below your line of best fit. Yeah?
With like the whole buying a car thing, and you have residual left, what would a positive residual be?
The positive residual is what you have left to pay for it. There's no negative residual for that, really. So for these ones, what we're trying to do is we're trying to actually figure out what is this distance between those points and that line of best fit. That's what our residual tells us. So they want to first know, in this context of the problem where we're dealing with our region scores, so these points are all region scores, region scores, region scores, region scores. What would a negative residual mean in this context? So what we have to keep in mind, this line here is the predicted value. That's what our line of best fit is that's our predicted value. So if my score is actually below that line, what do you think it's trying to say? You're not necessarily below average, but you're on the right path. It means you scored lower than predicted. And that's the key thing there, is it's compared to how you were predicted to have done. So in this case, we scored lower than predicted. So therefore, our positive residual in this context means what? So if I had a positive residual,
Now, did they throw in that 3 hours for like for you?
No.
No. Well, like it's extra, is it extra information, or do we need that 3 hours?
Well, that 3 hours helped us get the scatter plot. So a positive residual in this context would mean that you scored higher than you were predicted to have done. So in the context of this problem, would you have rather had a positive residual or a negative residual? Positive. Because in this case, positive means you did better than you should have done. So then part B, they want us to actually calculate the residual for an individual who studied for 3 hours on the Regents exam. So to find our residual, our formula up above says it's the actual value minus our predicted value. That's how we calculate a residual, actual minus predicted. So if we look at our table, what was our actual value for studying for 3 hours? What did the person score? Yep, 3 hours. That person scored an 80 on their Regents exam. What we have to do is we have to calculate what our predicted value is. So the way we calculate our predicted is you take your line of best fit, which was 6.27x plus 49.78. I got that from right up here. And then we're going to plug the 3 in. Do you think we'll plug it in for x or y? X. Guys, too much side conversation. Please stop. So we got to do 6.27 times 3 plus your 49.78. So what is their predicted score? 60. Point what? 0.59? Okay. So we're going to subtract that from the actual score. So 80 minus the 68.59 that they're predicted to have gotten based on our line of best fit. What was our residual here? Yeah, 11. 11.41. So that's a pretty high residual. So this person did a lot better than they were expecting to have done. So C, a student studied for 2 hours and got a score of 75 on the exam. That would be your actual value because they're telling you that's what they got, so that's their actual. What is the residual for this person? So just like we did for the last one, residual is actual minus your predicted. So as we said, our actual was a 75. What do we have to do to find our predicted? Got to plug it into our line of best fit, plug in our 2 hours studied. People get confused sometimes with their actual minus their predicted. You always got to remember, predicted comes from the line of best fit. 62.32. So now let's subtract 75 12 point what?
6.8.
12.68. So that person did even better than the other one did because their residual score was higher. Bless you. All right. Let's take a look at the back. So now sometimes what they're going to ask you to do is they're going to ask you to sketch a picture of your residual plot. So this is how you would go about doing that. Those are your directions to create your scatter plot. The one thing that you have to remember to do, and 99% of the times when people tell me, oh, my residual plot didn't work, it's because you didn't do this one thing. You have to calculate your line of best fit first. If you don't calculate your line of best fit by doing your linear regression like we did last class, then your calculator has nothing to use as a predicted value. That linear regression is your predicted value, so you have to have the calculator do that first, and then it can create your residual plot. So now what our residual plots do is, first off, sometimes they confuse people because your residual plot looks a lot like a what? Not a dot plot. What did we talk about last time? Scatter plot. This looks a lot like your scatter plot, so you got to make sure you read through the directions and see which one it is that they're actually talking about. This one here is a residual plot. So these are all the different distances from your line of best fit. Yes, Josh? So in order to interpret your residual plot, you have to be able to tell whether it's a good fit or not a good fit. The other word they like to use is linearity. So you can have good linearity or you can have bad linearity. Nope. So what that means is, with your residual plot, you want it to be completely random looking. The fact that your residual plot is completely random, that's showing that your line of best fit did go through the middle of your data, and you had some points above it, and you had some points below it. When it doesn't have a random pattern, but there's an obvious pattern to it, or a changing spread, which we're going to draw that picture in just a minute, that means it wasn't a good fit. So like, for example, this one clearly has a distinctive U shape to it. So that tells us that our line of best fit was not actually a line of best fit. It was not a good fit at all. So this has bad linearity.
This would be hard to do a line of best fit for that.
But this is the residual. That's not the data stuff.
Oh.
That's the residual. So what that's saying is, at the beginning of your line of best fit, you had a couple of points up here, but then your points were kind of down here. And then you had a couple more up there. So, I mean, it didn't really work. It didn't follow where the data went. Same thing for this one. It has a very distinctive upside down U shape. So that one is not a good fit. It has bad linearity. Now when we talk about changing spread, if I got my little XY axes on there, your residual plot, if it starts kind of wider, and the dots kind of move closer together. So here it's really far apart, and then it kind of comes together at the end. That's what we call changing spread, because they start wide, and then they get narrow. That is also telling you it's not a good fit. So random, good fit. Not random, bad fit. So let's take a look down here. The table below contains the values of all of the residuals computed, for example, above. So I have already calculated out all of the residuals for you. I did all of the actuals minus the predicteds for you. So they want us to create our residual plot over here, and they've already got it all set up for you. Your study hours would be the X part of your residual. Your actual residual value is your Y part. So this middle part of the table here, we don't need that when we're going to graph our residuals. You just need your X and then your actual residual value. So here, 3 And then 11.41, so I'm going to go 11.41's off my graph, so I'm just going to kind of estimate where that one is approximately. And then 5 and 8.87. So looking at this, does there seem to be any kind of shape or specific pattern to our points? No, this one would be completely random. So based on the residual plot, what can you calculate about the linearity of the original data? And all you would have to say is it was a good fit. So by saying it was a good fit, you're saying that was the correct line of best fit to use. So what we're going to do quickly is we're going to practice doing a residual plot in your calculator so we can go through the steps together. What I want you to do is type into your calculator study hours as your L1, Regents score would be your L2. 3, 2, 6, 7, 1, 2, 7. All right, so we got all our data in there. So as I mentioned, before you can create a residual plot, you have to do your linear regression first. So we're going to go to Stat. We're going to go over to Calc, and we're going to do our choice for our linear regression. And then you just got to let it run. So everybody did their linear regression? All right. Yep, you got to go over to Calc. There you go. So now to create your residual plot, we have to go to our stat plot. So second, y equals. We want the first one. If yours is not currently on, go ahead and actually turn it on. For type, we still want that first one. Second, y equals. You want your X list to be your L1. You want your Y list to say residual. So we go down. Then you want to hit second, stat, choice 7 is your residual. Second, stat. So again, if you have not done your linear regression yet, residual will not even be an option for you when you do your second stat. You got to make sure you do that part first. And then your mark, box, plus sign, dot, doesn't matter, whatever you prefer to use. And then we're going to go to zoom 9. You don't change that. Go down here. Second, stat.